This is homework set 18, reducing rational expressions. In question 1, our plan here is to reduce this fraction, this rational expression, to lowest terms. That means I'm going to eliminate any factors that might be common to the numerator and the denominator. And when we do this, it usually involves factoring. So let's see what we can do. Can't do much with the top, that's a 5. But with that denominator, notice the 5 is common, so I'm going to factor out of 5, and then what are we left with? Y plus 20 divided by 5 is 4. And now 5 into 5 will go once. So I end up now with, 5 into 5 will go once. So I'll write the 1. So I end up with 1 over y plus 4. Now typically what we will say here is this, that the 5's cancel. Now when I say cancel, what I mean is that I'm canceling unnecessary operations. Here's what I mean. Suppose we started out with this expression right here, 1 over y plus 4. Now what if I do this? What if I multiply by 5, then divide by 5? Well, I'm back where I started. So why would I do that? It's just inefficient. So what I'm doing is I'm canceling inefficient operations. So we're really making a division, right? When I do this up here, when I do this, I'm really making a division, but I just call it canceling. Everybody does. It's just a common term for that operation. And what I mean by canceling is that I'm canceling unnecessary operations, just to make things more efficient. Let's try to reduce this rational expression. You can't help but notice there's a 4. The 4 divides each one of these. So in the denominator, I'm going to factor out that 4. And what's left? 4 into 4 is a 1, so it's just a. And negative 12 divided by 4 is minus 3. And now 4 will go into that negative 8 negative 2 times. So now I'm left with this, negative 2 over a minus 3. Question 3, let's reduce. Now factor as much as you can. That numerator, can't do much with that. So let's just rewrite the x plus 3. But that denominator, you notice, difference of 2 squares. So we have a pattern for that. Write our parentheses, unsquare each. So x squared is x and x. The square root of 9 is 3 and 3. Make 1 plus, 1 minus. And now I can see that x minus 3 will cancel with x minus 3. But when you draw those lines, there's really a 1 in each place. So what I get is a 1 on top over, and in the denominator is 1 times x minus 3, which is x minus 3. Now, we're not asked to say it here, but this is true as long as x is not equal to negative 3, right? Because if x was negative 3, what would you get here? If x was negative 3, you get a 0 here and a 0 here, and then we end up with 0 over 0, which is indeterminate. Question 4, let's reduce. A lot of 3's here. I'm going to factor a 3 out of the numerator, so I'll get 3, and what's left? Y squared and negative 3. Negative 3 divided by 3 is minus 1 over 3. And now I notice this y squared minus 1 is the difference of 2 squares. Let's go ahead and factor it. So it's going to be 3, and then, difference of 2 squares. So unsquare y, 1, 1, make 1 plus, 1 minus, all over 3. And then, of course, these 3's cancel. So I'm left with just this, y plus 1, y minus 1. Now, I suppose, really, if I cancel the 3's back up here near the top, if I cancel those 3's, I'd be looking at this, y squared minus 1. That's probably an okay solution, but I want things factored and broken down as much as I can get them. Question 5, look at that numerator. We've got a 4 here and a 4 here. Let's factor out that 4. So doing so, I'll get 4, and then a plus 1, which just happens to match that denominator. So I'm going to cancel those. Now, remember, when you cancel, you're really left with 1. So what am I left with? I'm left with 4 times 1, which is 4. 4 over 1, right? So what I'm seeing in my head is this. 4 over 1, which is just 4. But this only works as long as a is not equal to, right, not equal to negative 1. Now, they're not asking us to say this in the answer on the homework. They're just asking us to put this. But this only works if a is not equal to negative 1. Now, if a is negative 1, what do you get? Right here, you get negative 4 plus 4 is 0 over 0, which we know is indeterminate. So I like to just write this so I know, but we're not asked to do it in the homework. Question 6. Look at the numerator and look at the denominator. See if you can factor those. Now, in the numerator, 7 and 35 have 7s in common. Denominator, 10 and 50, there's a 10 common. So out of the top, take out a 7. What are we left with? A plus 35 divided by 7 is a 5 over, now take that 10 out of the denominator. What are you left with? There was a 10. We removed it, so you're left with that A. And then positive 50 divided by 10 is positive 5. That's what we were expecting. And now you can see those a plus 5s are going to cancel, so we're left with 7/10. And this is going to work as long as a is not equal to negative 5. You know, here's what I'm getting at, just to be sure. You've got that a plus 5 here, and this in the denominator. That a plus 5 is in the denominator. I can't have zeros in the denominator. So what I'm asking is this. A plus 5, what's going to make that 0? So I'm just solving that equation. All right, so negative 5 is going to make that denominator 0. So I'm going to exclude that. That's an excluded value. Question 7. The problems are getting a little bit bigger now. Now notice I can take a 2 out of here and a 2 out of here. So let's do that. So take a 2 out of the top, we'll factor, getting a minus 5. And then the denominator, take a 2 out, and we're left with a squared minus 6a. Now, positive 10 divided by 2 is positive 5. Now, right away I can see those 2's will cancel. So here's where we are so far. A minus 5 over a squared minus 6a plus 5. Now, can we do any more? Are there any inefficiencies in here that we're not seeing? Well, we'll see them if we factor. So how about a minus 5, and in the denominator, let's factor this. Let's go with a and a. Only one way to get a 5 and a 1, and the 5 is positive, so these two numbers have to have the same sign. And that sign is that middle minus sign. So minus, minus. Now I was expecting that because I know how these problems are written. This is going to now cancel, right? So we're going to cancel that. And when you cancel, you get 1s there. So I get 1 in the top, and in the bottom, it's this 1 times a minus 1, which is just a minus 1. There we go. Question 8, let's factor. So let's factor that top, write my parentheses, and then I'll write the parentheses for the bottom, numerator and denominator. So how about the top, x and x? Now what do you want to use to multiply together to get a 12? Then when you add together, you get an x, a 1. Well, how about 4 and 3? All right, let's go with 4 and 3. Now they have to have opposite signs, right? Because 12 is negative, so they have opposite signs. I'm going to put the plus sign with the bigger product. Now, the bigger product, there's positive 4x. Well, here's 4x. Here's 3x. This is bigger. So I'll put the plus sign here. So I'll get x plus 4, x minus 3. And in the denominator, how about x and x? Now, what do you want to use to get that 6? A 6 and 1. 6 and 1, I can't get a 1 out of a 6 and 1 if I add or subtract. But I can out of a 3 and a 2. So I'm going to use a 3 and a 2. The 6 is negative. So they have opposite signs. So the 3 and the 2 have opposite signs. I'll put that middle minus sign with the bigger product. Now, here's what I'm looking at. The inner product, the way I've written it, is 3x. The outer product is 2x. This is bigger. So put that minus sign with the bigger one. Now, what do you notice? That the x minus 3 is canceled. So we're left with x plus 4 over x plus 2. And this, of course, works as long as x is not equal to, what do you think? What do we cancel? I don't want that to be 0, so I don't want a 3 here. So x is not equal to 3. Question 9, look at this numerator here. We've got a 3, a 6, and a 3, so there's a 3 common, and there's 3 a's, 2 a's, and an a. So I've got a 3a in common. I'm going to take out a 3a, and then what's left? Well, the 3 was removed. I had 3 a's. I removed 1, so there's 2 left, so a squared, and 3 into 6 is 2. There were 2 a's. I removed 1, so 1 left. And now, this happens often. What I'm taking out, all right, what I'm taking out matches identically to what I have. 3 into 3 is once. A into A is once. 1 times 1 is 1. So if what I remove is exactly what I have, I get a 1 there. Now in the denominator, let's just see if we can factor this. So how about A and A? Only one way to get this 2. Only one way to get a 2 and a 1. And the 2 is positive, so these two numbers, the 2 and the 1, have the same sign, which is that middle plus sign. But now what about this one right here? What about that? Let's see what we can do here. So 3a, what are we going to get? How about A and A, 1 and 1? Only one way to get a 1. How about plus 1 plus 1? That'll give us the 2 over A plus 2, A plus 1. And what do you know? We get something that matches. That A plus 1 will cancel with one of those. So here's what I'm left with. 3a, A plus 1 over A plus 2. And this works as long as A is not equal to negative 1. That ends our first group of problems in homework section 18.